All right. So the topic of today's stream is going to be this new project. I talked about it a little bit in one of my latest dev logs, so some folks have already seen it and started checking it out. But it's the first time I'm streaming it. It's been spinning out of the RPG simulator project I've been doing this whole time. So it's not new to anyone who's been following the RPG simulator, but it's a more of a research-oriented project than just exploratory. This is more of a specific concept now. And so I have a space where I'm going to iterate on it, and I'm thinking moving forward what I'll do is I'll probably stream Thursday, Friday this, and Monday, Tuesday, Wednesday, I'll either stream or not stream as I'm feeling. So I'll keep using that as exploratory time and see where the RPG simulator is going on and off stream. But then today and tomorrow I'll hang out here, and we'll work on C scripting. There's actually a lot of stuff to do with this project. So part of what I want to do today is introduce the main concept to everyone, since it's sort of the first stream of it, the first video announcement of me working on this explicitly, and then go through a bunch of the things that aren't ready or that haven't been figured out entirely or that could be improved upon with more coding put into it, and make a to-do list of research and development stuff to do. So first of all, let's talk about what it is. So C scripting, I have no idea what I should actually be calling this. So let's just right up front, I talk about this here. It's kind of I'm trying to solve a problem that I feel intuitively, but I don't think programmers have a name for it. And it's sort of felt, and the thing is not every language has it. If you're someone who thinks it's silly to always be in C because you can just switch to Lua or JavaScript or something and express certain things so much better, there are all kinds of reasons why that's pretty true. But some of them to me feel like solvable from the C side. And if you're gonna have to write in native, it'd be cool if as much flexibility from the scripting world was available to you as possible. And there's just this hard thing I don't know what to call it. I'm sure that some programming language people have a name for it already, but it's the difference between a language where you can run, like when you run a Lua script, I know what happens is the script itself is like a series of things. They might look like global variable declarations at first, but they can actually contain logic and do stuff. So you can write code in an include that does some little work on startup, and the code is sort of able to initialize itself in very rich and complex ways. And C is not like that at all. If you have an example here is if you have that I wrote into the intro here of the C scripting thing. Actually, I was going to just start explaining C scripting. I want to give one more piece of information about the structure of the project now that I think about it. This is currently in the members only section of the getmrforth.com. So if you're watching this and you're not a member, you won't be able to see this yet because this is sort of work in progress stuff. So members get to, take a look at this and use it whenever they like, because I've made it a license for them. I'm not sure if I actually included the license now that I'm looking at it. I intended to license this so that members can start using it as is, no liability, no warranty or anything like that, but also just to not propagate it to anyone else after they start using it, right? So they can't use it in larger teams without talking to me about it. The reason for that is, one, I would like to incentivize people to support me on working on this kind of stuff, so you can become a member to start checking it out sooner. And two, it's also just not super ready, so it definitely needs to go through some iterations before I put this idea out there fully. So having it in a sort of a circle of people who I'm interacting with more closely and who know that I'm warning you up front, it's really not ready. There's a lot of edges that need to be worked out on this idea. But that's the situation. So we're looking at a repository that I have on my getmrforth.com for the members. Now, the example that I talk about here is the example of a command line interface. So if you've built one of these before and you haven't used a tool, like if you've built one from scratch in C, the experience is of having this problem of binding some information together with some kind of computational binding. It has to map from some kind of name or abbreviation of a flag to some code that needs to run. and affect the main computation that's supposed to happen, right? This is somehow supposed to bind that information into the computation. And there's a couple approaches. There's the immediate mode style where you go, okay, check, here's my context. I've already parsed the arguments, and here's a argument name and an abbreviation, and maybe there's a type of like sub argument. Sometimes flags come with an argument, right? And then some documentation information, and then finally the block of code that comes after the if represents the binding into the main computation, right? So that's one way we solve it. There's then this idea that you could make like a data table driven version, and you could use function pointers. This has the advantage over this one that it's now a data structure, you can inspect it. So if you want to do fancier things like use this information to drop out a help menu, after what you would probably do with this API is you would gather it all up into the context and then dump it after, right? And you would have all of these always fail because you're not actually trying to compute, you're just trying to build the help menu. So you run the code with sort of different variations of the context transforming these ifs. That's the immediate mode style. With this, you just get the data structure you want from the beginning, right? The idea is that you wrote it as a data structure. So if you want to iterate over it and build a menu, that's available. But you have to now the data you're binding to the code block aren't together. There's this intermediate name binding process that's got to happen, right? They can no longer be bound by proximity from it's not just put these things next to these things. That's what we get up here. We put these things next to these things. And the second thing we get here is that we have global variables and local variables are all just available. An entire context of code from a containing scope is available here. That's a bonus that you get here. That here you got to pass through like user data pointers and stuff, right? That's a degrade from this, but the upgrade is that you've got the data structure as a data structure, and you can work with it as such for building menus or helps or autocorrects or whatever. Another approach is to metaprogram it. This is what I would do in 4Coder back in the day, is you put a macro down and you'd say something like, okay, we're going to scan the code for this macro first and extract all of the information. And then when the macro expands inside the actual code, it will just use that as the function name. But when we scan it, we'll grab all this extra data and we'll make a separate data table, right? So we'll scan our code for this macro, generate some data table, and now we've got the best of both worlds, right? Like the data is bound next to the block. So you've got that, and you've got it in a data structure at the same time. And so now the only downside is, of course, you have a whole meta program in your build, and it's a custom. Each one of these is like another meta program. So once you're done with your CLI system and the meta program for that, you're going to end up building another meta program for the next thing that you won't have the same, like your UI or whatever the next problem is, where you're binding these blocks of code somehow to data. And so the idea is C scripting was what I was calling it. If I could find a way to solve this that was free of meta programs and was the best of both worlds, that was the idea. Because if you could just do this innately, like if you could just say, I want a data table that corresponds to a bunch of function pointers bound into data, then you could do all of this very cleanly, right? You wouldn't need meta programs, and you wouldn't need to decide between immediate mode UIs and having a data structure that represents your pieces that you have to construct it, like register, have a list of things to register. All of that can go out the window, and you can just start binding data to code in this new way and working with it. So I found a way to do it, and it sort of works. It's got some downsides, and they can all be fixed, but it's going to take iterations, and it needs to be tested on multiple compilers and operating systems and linkers and so on and so on. And I've done some of that testing on my setup. So on Windows with Clang and Microsoft compiler, and with Clang and the Microsoft linker, with all the different options for optimization that I can find, I can't find a way to make it break, right? Like so for my local space, I've done some vetting, but there's a lot of more stuff I haven't done. I haven't done any of this on Linux with ELF files yet. It's all Windows. I haven't done any of this on the GCC compiler or any other types of tool chains. I don't know how far it goes that you can do what I'm doing. But what I'll do next is I know I've got a question in the chat, I think, so I'm going to go read it because I can't see the whole thing from where I'm sitting now. And we'll chat it for a bit, and then we can talk about how I'm implementing it and start working on that to-do list hopefully today. So Ben is asking me if version 2, I assume you're making a little joke here, like an upgrade to see how much of this is about having closures and lambdas. I think that there's something slightly different. Closures and lambdas would let you do another version of this, right? So if you could say write some function code here, or procedural code here that simultaneously binds this stuff in and hooks the block in. That's still better than this in a couple ways, right? Like it's a data structure now that you build at runtime. There's still a cool advantage to this, which is that it's pre-built. Like this API here entails construction at runtime, just because that's like how we're putting data in here. This goes a step further and says the compiler could actually be arranging this data table, right? So that's one thing that's still better here. If you could then stick a lambda right here, like go, square brackets or whatever the syntax is, lambda, write your function right in line here, that's another step in the right direction. And that would probably be a way to solve this. Yeah, it cuts out the intermediate name in the same way. It lets you bind this right to this. So honestly, I think that while maybe not syntactically the same, there's still one thing that you can't do that I can do with C scripting that I'll show you. But yes, this does get you most of the way there, because then you have the ability to bind the data right to a block in a data literal like this without needing to separate the block out with this extra name. And then the only limitation you have left is in the data, and I skipped over this when I was laying this out, but in the data table version, where if you do it this way, you have it built at compile time. You have to put them all together. Like you can't declare new ones sporadically. And very often with things like, with CLI flags, you can imagine doing this all in one place probably, because it's so it's like a choke point. But with something like forecoder commands, you have a different desire. You want to drop new ones in freely, and so with that, in forecoder, the only solution I had was metaprogramming, because this was the only one that lets you drop them in freely. This only lets you drop things in freely in the sense that you don't have to put them all in the same spot like you do here, but you still have to hook them in manually somewhere, right? You have to get something to call you eventually. And so sooner or later, if you want to have a system where you can drop new hooks into a data structure, how do I put this, from other code, not necessarily at runtime, but from code in another file, or maybe even from code in another module or something, then you still end up wanting some kind of declaration style syntax like this. Right? I think this is the most ideal setup syntactically, even if you have lambdas, but it would solve a major problem that both of these have if it had closures. I think it gets you like 80% of the way there, but this thing here unlocks another trick. And this can happen in a language, like I said, like JavaScript or Lua super easily, because this is just a global declaration that constructs a little data structure, right? And so you can have them spread out in something like, say, Lua, because I am familiar with how you can do stuff like this in Lua. You can have, before you set up your Lua context, there's a global variable you create that's going to be your table, and then you can include a bunch of scripts, and each script can define, an entire set of functions that hook together in a certain way, and then the final thing the script can do is just register that table with the global. So it's just like a one-line add to say everything I did in this file, hook it in like this, right? And then if you need to hook multiple things in a file, that works. And so that's why I'm calling it scripting, is because of that ability to affect the initialization more powerfully by just adding declarative stuff rather than having to go find int main and modify it in a centralized place. Does that part make sense? Because I think that that's a part of the one of the key things that C scripting includes is the ability to do that piece too. Anyway, um, so the next so I definitely need to write these better. I haven't come up with a good example besides this one, because the only other examples I have are straight out of they're either 4Coder or the RPG Simulator has a few of these now, or a bunch of these actually. But the this is the only like sort of more generic one. I need a couple more good examples. That's one of the things I need to put on the to-do list. Why don't I do that actually? So we've got C scripting here. I'm just gonna make a to-do.txt for the whole project and start going. So one thing I need to do is think up better introductory examples. I need multiple of those. Data sections. Okay. So I'm going to talk a little bit about how I do this now, because what I'm saying is I've made a system where I can kind of just make an arbitrary number of these things that are basically just a macro that binds a new symbol into a bunch of data and organizes it into a data structure that you can just introspect at the beginning of your program, right, immediately. And the way it works is what I'm going to get into. Something occurred to me and then it just slipped away. Oh, right. So the naming problem. I do think the name C scripting is a little confusing. The reason I picked it is because of the way it correlates with doing something in a global scope that is sort of declarative up front, that constructs a data structure. So that's kind of what inspired it. And that was what I was looking for. But now that I've sort of found a solution, the solution isn't C scripting. C scripting was almost the desire, the unmet desire. I wanted a way to code this way. The solution is the symbol set, right? The symbol set, and I haven't decided if I should just drop this name C scripting. Maybe it'll be too confusing to explain why I was calling it that in my head for a while. But now that I know how to do it, I'm doing it by this thing I call a symbol set, and I'm going to tell you a little bit about how I'm building that. So hey Tool, yeah, I'll go over it again. That's what we're doing today, as I'm going over it and over it. What I was just saying though is that C scripting is a confusing little name, and I think a part of what I like about it is that it makes people say you need to explain what you mean, and that's good. That it can't be misinterpreted too easily, and then I can explain what I mean. So very briefly, C scripting is the ability to do stuff like you can do in a scripting language where you have declarative code that affects and builds a data structure at a init time, and in a way to do that that's powerful enough to get a lot done with it, hopefully, right? That's what I want out of C scripting. So the idea that you could like declare a new flag for your command line anywhere in your code, they could just be dropped in. They don't need to be centralized in an enum, or an enum switch that's spread out in 2 places or 3 places. So it doesn't need to be it doesn't work as classes. Like C++ classes actually don't do this either. This is something different. This is just the ability to say this data here and this function block here are all bound together inside the data structure of the flags, like all of the flags for the program. So it's got a very flexible feeling to it, like a scripting language. But the way I finally made it work is by building this thing I'm calling a symbol set, and I want to explain a little bit about how that works. So Uh, duh, 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 duh. And yeah, my naming is confusing all throughout this because I'm still calling it C scripting here. I don't think it was until the very end of writing this that I decided I should switch to talking about the symbol set more. I'm still working on how to introduce this, right? This is day one. Um, I wrote this 1 week ago to get the idea out of my head, and now I want to make it good, and it's probably going to take a while. So the main thing we're trying to avoid, I'm saying here, the main thing we're trying to avoid is having to make a list of functions or like generate this or something or whatever that separately has to register each piece of function to the data structure that binds them all together. And so the way I am doing this is by placing them in separate data sections. So a data section is a part of the structure of the data, the file format that actually describes a program on both the COF PE side and on the ELF side. So they have this in common as a concept, which is that there are these data sections, and a data section is just some code, some bytes, basically some binary, together with a little name that usually looks like .data or .text or .r data and stuff like that. And it's possible in most, at least sort of industrial C compilers, to add a compiler specific modifier to a declaration that places that code in a different data section. So I started thinking about this for a while and thinking, what if you have a data section where each variable you placed in it was the same type? What you would get is basically an array, right? It would put all of your globals together next to each other, because that's what a data section is. It's a way of organizing all of this. All of the things that are declared as a member of this section get organized together. Now, there's no guarantee about what order they're in, but that doesn't matter if they're all the same type because you know how to iterate the array anyways, right? And there's fancier stuff you could do. If you wanted to get crazy about this, you could pack in non-homogeneous types that are parsable. But I'm not interested in that right now. What I'm researching is just arrays. Arrays of homogeneous types. And so the idea is you set aside a section for your new symbol system, your new symbol set, and you make a type. You decide what type it's going to be. And what you get is an array of that type that you can create by declaring global variables anywhere you want in your code that contribute to that array, right? So the array isn't centralized. It is gathered out of these contributors. And this is all done by the compiler and linker. So by the time your program starts, it's just a pointer and some small indexes, right? It's a set of each of these symbols, right? So in this case, foo and bar, they're either at slot 0 or slot 1, right? Each of them gets an ID this way, right? And each of them gets the memory set aside for the data structure, and it's all set up before your program runs, right? It's instantaneously available just by loading the program. It's just global variable data that you are accessing. Now the next couple of iterations past that, so that's the beginning of the idea, but there's some downsides to just handwriting it. One is that it's redundant. Like you have to correctly maintain this coupling on all of your declarations. Want to fix that. Two, I haven't actually set this up in such a way that I can bind the syntactically, I'm not getting to bind the function to the data because I'm missing closures, right? So I got to fix that still. And that's where the macro comes in, is to fix the coupling here and letting us bind the hook in better. So I include some code here for showing you how you declare stuff into a section. The second piece of this puzzle is just because you have something in a data section doesn't mean C has actually given you a way to bind that into the code exactly. And that is solvable, but only if we are willing to start modifying object files after they're generated by the compiler. We can do a lot of magic if we go down that road, but I haven't started building something like that yet. The farthest I've gotten is we can generate object files and we can parse object files, but it's very clunky still. There's going to have to be a lot of development work to really work out the the language that you want to use for manipulating an object file in place. So then you could do something like, say, create a global variable that represents the beginning of this data section, like the pointer to the base of this data section once the program is loaded, and that's totally possible. Like that, there's no reason why we can't do that, but it's not built in, and so we would have to hack it in, and haven't done that yet. But there are other ways we can do it, and so the way I'm doing it is with this sort of self-inspection mechanism. So it's pretty easy on each operating system to just say, give me a pointer to the data that represents the image of this program, right? So the image of a program is just the binary file, those data sections, right? There's a header and then some data sections. The binary file becomes an image just by sort of shifting the data sections around a little bit. They're packed into the file with a granularity of like 500 byte blocks of 512, I think, but they're packed into the virtual memory space with an alignment of 4K. Okay, and that is a a good moment to stop and say, each data section you do this with has a minimum size of 4K. They have an allocation granularity of 4K in your final image. So if you were to make 100 of these, you would start, and put a couple things in each one, you would start wasting memory at an alarming rate, possibly, especially if you're like in an embedded situation. This isn't going to work for you because this is going to waste so much more memory, right? If you're under memory constraint, there's a problem there. That problem is solvable. Again, object file editing magic could solve it because you don't actually need that data section. You just need to know where the array is. The data section is just the first way to do it without actually having to modify object files, right? This is a way to get this working without having to do object file modification. But I'm keen to go down the object file modification route in the future because then we could sand off these issues like, hey, you actually are kind of allocating yourself into a large granularity page system with each one of these symbol sets that you set up. So it's like I said, it's not fully ready to be pushed out there. We get some iteration to be done on the best way to structure this tool. Okay. Once it's in the image, once the data is in a data section in the image, the loaded version of the program, we can just ask the operating system to give us the pointer to the base of that. It's just some file, or it's just some data in our memory space already that C would normally not offer us a way to access, but the operating system does. And once you've done that, you can parse it like it's an image file or a binary file. It's the same format. It's just it's now in that virtual address layout instead of the file layout. And so you can scan for the data section you're looking for, right? You give it a name like .mything, whatever. You can scan yourself, your own data, the image of the currently running program at runtime for that one data section at initialization time, right? So at initialization time, you're going to scan yourself, find that data section you're looking for, and then get a range for that data section. And that's how you set up the array right now. It can be done at compile time if we go a little farther, but right now it happens as an init time process. Now I automate this so I don't have to go and hand register the data sections either, right? If we should take a look at the let's take a look at the code real quick for the example. The way it looks when you do one of these is like this. So you've got these command script things, and I've got some data bound into them and some stuff they do, and it's a terrible example. It's just foos and bars that don't make any sense. I have to actually come up with a real example still, but it's doing what it's supposed to with regards to the symbol set. And you can see like main just like starts using it, right? There's no set up the command system, set up the data section, set up foo bar baz. None of it gets registered. Once you get here, all of it is already referenceable. You can start referencing the foo, bar, and baz. You have to wrap your references like this right now, and I think you might always have to wrap them in a macro of some kind. The reason for that is this is actually not a variable name. We're using the foo there to link this to this as a member of the command sort of symbol set. But the actual variable that gets declared isn't just called foo. it's marked up a little more than that. Now, maybe there's a way to sort of simplify it down to a world where I'm not doing so much symbol name manipulation by the macros. But there are so many cases where it's helpful that I kind of just leaned into it in the first few iterations. But there's work to do on just the finding the most ergonomic uh, starting point for a tool like this, and deciding like if it should be uh, how much should be in the C code and how much should be object file editing. Should there be a version that's free of object file editing? Maybe there's a lot of stuff to figure out about this. I think throwing that into the to-do list here, one of the things to work on. Do I want to maintain a pair of versions, one for one with object file editing and one without? That's just a thing I'm wondering about. And the point is, it's a little bit annoying to actually reference these, but it's not that bad. It's as bad as like if you were in a language where anytime you have an enum command and you put foo and bar in there, right? Then if you wanted to reference it, you had to do this. It's about that complicated, except the syntax is like this or something, right? So in terms of how much coupling and stuff is happening, it's exactly the same as a language where enum values aren't in the global scope. They have to be accessed. It's the same amount of syntactic complexity, but it's a little bit more verbose the way it is in C with the macro. So I don't know. I don't think it's a big deal. I got pretty used to it pretty fast. But there might be other ways to do it still. Display the legend of rules. Yeah, I'm seeing Ben and Tool are both talking in the chat about ways they had to sort of hack something like this into a test system, or like some kind of function dispatch, like procedural dispatch system for. Uh, I imagine when you say interpreter, like we're talking like a scripting thing where you got like built-ins need to be referenced somehow, and so you got a bunch of function pointers and names bound to them, right? Yeah, it comes up a lot, and I feel like we all just hack it every time, but we need it all the time. And that's why it's just been on my mind, I think, for a while. It really was a big sticking point in 4Coder's custom layer complexity, that it was so under supported, and I had to hack so hard. And so getting a style of solution that fits in a header would be so nice, and that's what I think I'm getting close to. Um, so what I was trying to get at when I came over here, though, is just to say, like, yeah, there's some weird syntax problems with referencing stuff on this system right now. And so, like, if you want to get one of these as an ID, you give it the foo name, and out pops the ID. If you have an ID, like up here, I put the IDs into U32s, you can also map IDs to the metadata. So this gets back all the data that I registered here and the function pointer to this, right? For each thing that I have an ID for in the command ID. So I can go ID to metadata is the point. And the metadata here is just the struct. That's what I'm trying to say. It's just the memory in the data section. And that's it. Like that's just what you do. You can also iterate the symbol count set. So you can say, like, give me the base pointer to all of the symbols like this, and give me the number of symbols, and then you just scan them as an array, right? Like that works just fine too. The reason it uses these macros here and these macros here has to do with whether or not the person using the system chooses to wrap it. So like here I'm using the symbol set name right? There's the syntax problem that's coming up. That's like you could just always directly call to my symbol set macros, right? You can say symbol ID, and then the name of the symbol set is x1 command symbols, and then the name of the symbol is this n in the macro, right? And so I wrap this because even though this is also the same amount of syntactic complexity as this, it's so much more verbose. Um, that it's almost like necessary to add a wrapper macro for the basics. And then for something like a symbol set, base pointer, or count, it's not something that I need quite as often to feel like I can reference it freely without getting stuck on remembering the long syntax. Those ones just seem more intuitive. So I don't know. I haven't quite sorted out how I feel about it. Maybe I just start practicing doing it this way and I like it, or maybe I give up on this idea of need. Like maybe I decided the macros are never going to work once I've got object file editing and just get that out of there somehow. I don't know. But but anyways, let's go back to that. That's just looking at the code a little bit to show you a bit about just how much I mean by automatic. It works. Like there's no registration, and the only registration that kind of does happen I can automate by also using a before main trick. But we also don't need this registration if we get off of the once we get to the point where we can modify the object file just a little bit. We wouldn't need to inspect the image anymore. We could just build in all the stuff that's supposed to be there with the modification to the object file. And so then that before main part can go away too, actually. So I guess the rest of this, I'm just sort of explaining how I build out the rest of the features here. The basic idea is once I'm making a global variable, in order to get to the point where I can bind the function part in, I start by wrapping the declaration line. So we had up here, I was declaring a global variable and putting some data on it. And then I explained a bit about how we're going to use that. And then to make the syntax better, I put that whole thing inside of a macro. And then what we do is we actually declare the function and define it within the macro. So this is a trick that you can use in a couple of different spots in C. What you're trying to do is you're trying to build a syntax where the macro cuts off at the end of a function declaration that you can transform into a definition by putting the braces right there, right? So this brace joins into this right here, and it becomes a function definition, and then you declare it beforehand so that you can hook it into something else, right? This is just stuff we have to do because we don't have lambdas. That part could be a little different with a better language support, right? You could just go, I want a thing, I want it in this group, here are its members, here's a lambda for the hook, right? You can imagine it being just a feature of how you declare globals into symbol sets, and a closure would have eliminated the need for a C macro, but without that, C macros actually let us get a lot done, so I'm doing it that way. What else do I want to introduce? I think that's pretty much the main thing. I mean, I often end up eliminating the need for putting the name in there at all, but since I sometimes want to reference, well, yeah, here I eliminate the hook and I just have a symbol name. I can also go as far as saying we don't even need symbol names sometimes. Sometimes the names don't matter and only the array matters. I haven't talked about that here yet, so I guess I could talk about this. Example for symbol sets with instances that don't need names. I probably missed some other good to-dos while I was running through that introduction, but that's the whole intro. That's how the symbol set is set up. It's a data section that gathers up all the instances of a struct, and then a macro that wraps the declaration and the definition of a hook into one, so you can stick all of the data that you want as well as a name for the symbol into one line, and a block can come after it to define a function for it if you want. You can also do this without needing, like sometimes it's nice to be able to do this with just a few pieces of data and you don't need a hook involved, and then you can eliminate that part. So it's very flexible. It's just a data structure, a struct of your own making, thrown into an array that is gathered up from declarative pieces rather than specified in a centralized list. That's what it is. And there's a couple other cool things about it. Since each one of them can have a name, that name is still a global variable. You can just use the name to reference the thing, right? We use this name to reference the global variable. But we can also then use that name as a binding to an ID if we want. So we can actually stop passing these things around as pointers to my things and just use 32-bit or even 16-bit IDs. Like whatever is enough, you can just use an ID of that size to reference these things, because they're ultimately going to be like a global array and not changing. Although I guess it's a good point. Here's a good thing for putting my to-do. I need to do some research stuff. So here we go. This is example writing to-dos. This is solution structure research or something like that. The structure research, I don't know. The next one that popped in my head just now is I had something. How did I'm having a short-term memory problem today. I think it's because I only have coffee and not water. I should probably go give myself a water. I feel like my mouth is very dry. What was I thinking, though? I'm disappointed that I'm forgetting. What was the structuring problem? This is a bunch of data sections, global variables, reference them by name, and get an ID. You can pass them around as IDs, access them. Mutability. So I guess this is actually in two parts. There's examples of more complex data initialization via the hook, and this is what's the right word here? Test out the boundary. Test out the. Explore the trade-off of using the hook for more complex data initialization. So what I'm talking about is one way you can use this is that the hook, and I've been doing this, like some of the stuff I do in the RPG simulator looks like this, like I think some of it looks like this, this kind of thing where it's like we're just making a thing, binding a name and some stuff to it, and then just some code that we want to have happen sometimes, right? The simple version. But then some of it is like this block here is not code to run during the main program. It's more like additional initialization that is more complex. The data structure needs some arena, or it needs some it's going to do more stuff. So you could imagine, for instance, if these are going to be assets in a game, you're going to give each asset a symbol, and then you're going to give each asset a file name, but you might also then be like, well, this asset, I want to set the origin here, and I want to set the color tint to this, and I want to set this and that. And like, you might have a bunch of extra settings on your assets that you don't want to cram into a macro. This would be a way to make a declarative setup, but you would still have to run init code, right? You would still, at init time, what you would do is you would scan this symbol set and run everybody's init hook. And there are some cases where there's just the init is so varied and there are so many parameters that feels like the right way to do it. I don't know exactly what recommendations to make or where the boundary is from one type to the other. So that's what I'm talking about there. I want some examples of thinking about it that way and using it that way. Um, what else do I want to include as to-dos? Well, I'm going to take a quick break, not a 5-minute break. I'm going to just walk over to get my water, let all this that I've chatted about so far just sit for a minute and see what we want to do. We can play with an example and build out more stuff. We could talk more about to-dos. I have a couple of, I know there's at least one bug in it right now in my example that I can fix. And so I could talk about that and think about, tools, what inspection tools support this style of programming, right? I want to be able to see what I'm doing. I don't know. I'm going to be back with water. 1 minute. All right. Let's slow down for a minute and see what we might get into. So let me show you the bug in the example. So this is the example. We're inside the C scripting repository here. And when I build and run it right now, it's working, except you see this? Here's where that's coming from. I am iterating all of my command symbols, and the count is too big. Now, this is something that I think might be an initial concern whenever someone looks at what I'm doing. If you're familiar with data sections, one thought you might have is, what if other people what if the data section has padding? What if you can't get the count accurately just by looking at the data section in the image? What if it introduces like a random integer between the first and second struct or something, right? What's to stop anybody from doing that, right? Technically, nothing is to stop it. This is well outside of what C has actually specified, right? But from a practical standpoint, it's actually much less polluted than you might think. Which I claim while staring right here at the evidence that there's some kind of extra data in my data section. But the thing is, I actually figured out what this is beforehand. I just haven't gotten around to fixing it yet, but I was figuring this out last week. So I just haven't put the fix in yet. So why don't we do that today? Let me show you how I figured this out and then what we got to do. So what's happening is I'm scanning these symbols and I'm printing out their names, and then there's only 3 of them, right? The example contains foo, bar, and baz. Each of them is a command. It's got a symbol name and a documentation string that describes what it does, and then some code that does it. So this generates a foo, and then it increments the foo counter. This generates bar and decrements the foo counter. And then this one generates 2 bars or 2 foos or a baz, depending on the counter, the foo counter. Right? But it doesn't modify the counter at all. And then I made a sequence, and I ran it, right? So here's the sequence, and then when you expand that sequence, this is the output of running the commands one by one from that sequence, right? So we get foo prints foo, foo prints foo, baz prints bar bar, bar prints bar, baz prints bar bar, bar prints bar, foo prints foo, bar prints bar, baz prints baz, right? Like that's what just happened here, right? This is the in out of this silly little command example that doesn't make any sense or do anything, but that's what I've got so far as an example. And then there's the question, like, what's all this, right? And so at first I thought, it's just the whole idea is shot. There's padding after all. But actually, when I went and looked at what I was doing in the RPG simulator, I was pretty sure it wasn't happening there. And I discovered that as I thought, it was giving me the correct counts on types that were just 1 byte, on types that were multiple bytes. It was giving me the correct counts on most of my sections, but on a few of them, there were some extra things popping in. And looking at the difference, I figured out what it is. So I suspect that if we were able to look into this binary file after I've generated it and look around, we might be able to figure out where this data section is. And we would see that what I have in this system here, I've got this, in this example, I've got a data section called .example1 command, right? That's what the abbreviation is. One of the catches here is these data sections can only be up to 8 characters. The first one doesn't have to be a period, although it often is. So, like, I'm following that convention just because I haven't decided to play with not doing it yet. It makes me nervous. Maybe it's silly to keep it, but that's how they do it. So there's a dot, and then you get 7 more characters. So I'm always, like, hyper abbreviating on that part. It's a little sad, but it's the only way it works right now. The type itself has a name string, which is the foo, bar, or baz. So the name is being generated out of the symbol name. The description, which is this string, and the hook, which is the block, right? So that's what my command looks like. And then my macro just has to splat those 3 things in. The n gets used several times, once for the symbol name, once for the name inside the struct, and once for the hook name. And then the description gets used right here, and we get ourselves a globally defined, or globally declared and defined example1 command with all that data stuffed into it. And then the thought is, this, remember, is a macro hiding a data section declaration saying place into this section a global variable with this type, right? And then I put these string literals in there, right? This and this become string literals on the same line, right? In the same declaration. And I suspect that what must be happening is that these strings are also going into the data section after the array. So the array is still showing up in order, luckily. But I think it is deciding to put the string literals in the same data section as the variable that they are contained within. And so I think we can verify this idea a couple of different ways. One way we could do it is to say, let's just see if I got it right. What we'll do is we'll declare command name n equals, so I'm just pulling the strings out and making them into separate variable declarations. This comes out and looks like this, command description, and then they get linked in but not placed in the same data section. So I suspect that if I build it this way, but you don't think that's a constant, right? So what we have to do instead is we have to do you are not a string 8, you are a u8 buffer defined by this, and this is, why don't we just do it like this for now? Well, I think that the macro would still work. Yeah, so I should be able to do command name n right there and command name description right there. This is the worst part about it, is that I have to work through the preprocessor pretty heavily to make these declarative macros. And one way I could probably solve that is if I was willing to just embrace C fully and use like the full power of the declarative structure of C's, like, you know, I should be able to just say dot name equals dot description equals and stuff like that. And I might be able to then find a way to work this so that you don't use macros at all, or you only use a macro to like label and type it, but you give it a name yourself, right? Like you could imagine that this might look more like command symbol, and then foo equals, and then dot name equals foo, dot description equals this, right? And you would still be putting these into like this kind of thing, I think. But you could imagine getting to the point where you kind of embrace declaring them like this. I really like the feeling of having it in a much better syntax. Now that I'm typing that, I see why I'm not doing it this way. You'd still end up with the problem of the hook having to be like here and like up here or something, right? You'd have to go command hook foo, right? So there's some downsides to trying to get off the macro part, which is that C's ability to do declarative work is limited to begin with. But this could be a style of a general version that lets you do all of the stuff after just setting up the data section and the type as a single piece. That's kind of an interesting idea. Let me put that into this to do. Could this work? Could this work at a layer? Could symbol sets be defined? Definitions, syntax be organized in such a way that it's just a data section and type wrapped in a macro? That kind of seems like where this could actually go, right? The command symbol would just be define command symbol as, and then the section that you care about, and then the type that you care about, and the rest then you can declare it like this. Man, that works really nicely. I feel like that's just another breakthrough just right there. See what I'm saying? Like this works as a declaration for the symbol foo, and I can do as many of those as I want. This then could be turned into a definition just by putting a brace here. Right, an equals brace turns this into a definition. And then if you are me and you want to wrap it in a macro that packs all of the strings in and wraps the hook in for you, then you still have that option. But you could also just say, hey, I'm just setting up this. It's just such a lightweight technique. There's almost no code. All you really need is the data section wrapping thing and the ability to read the data section back out. That is the hardest part, is having the ability to inspect and pull out your own data section. But a lot of this you could just build yourself the more I'm looking at it. Like this seems to simplify it even more than my command ID or symbol IDs. The symbol ID is a little hard to replace without some heavier data duty work. If you want this to be a thing where you just use pointers to reference your symbols all the time, then it's a little easier. But the moment you want the extra step of getting small consecutive IDs that you can reference statically, you need a little bit more help, because that's where you have to subtract you basically do a pointer subtraction, right? You take right now what I do is I take the symbol that I'm looking at, foo, and I have to subtract the base pointer. And the base pointer is figured out at init time. Or it'll be figured out by the object file editing magic that goes in between compilation and linking for this system. Either way, though, you need a little bit more help there if you want that feature. So the most lightweight version is just no small consecutive IDs. But small consecutive IDs are really cool for lots of different reasons. It means now, if you only need 16 bits to reference all of your symbols for the rest of time, for instance, then you can pack in an ID with so many other things that you can start using them as keys on, hashed data, key values into a hash table. So you can dispatch on multiple combinations of ID sets or symbol sets at the same time. And you can use it for things like creating data structures, you know, like arrays for having metadata that you have about each one of them. Or stuff like that is just really nice to be able to do. The guarantee that you know there's a small consecutive ID system just lets you do a lot of stuff with it. And I think that that's worth hanging on to, even though it means you got to do more work. But I think I could make the small consecutive IDs still work without having to actually, quote unquote, define a symbol set, right? You would create a symbol set out of ordering them into a data section here, and then you could just go, right? You could manually do the like deal with the coupling of that type to the data section in your wrapper, rather than trying to have a symbol set system that binds them together into a different name. I was trying to make it so you could create like a thing that looks like a macro or something like a type, like this command symbols thing, and then use that type to access the various aspects of the symbols in the set. And that does have the nice feature that you don't write the data section more than once, you don't write the type more than once. They both get written here, and everything else works by reference to this name that binds these two together. But it's a nasty way to define things, and it makes you have to... It pushes you to the point where you're doing this just to define one of them. I guess that you could just drop that as a global variable anywhere too. I don't know. Again, with things like wanting to separate out these data sections, it ends up feeling like you have to engage with the macros. But okay, that was a cool little exploratory moment. I think that there's something there to consider. I'm gonna put it back to working like it does. Build it, run it. Okay. I didn't manage to shrink it at all. So I think that my solution isn't working. I need to look at the data structure now. Hex. Where's my hex editor? There it is. We're going to need to look at... Where is this? Side projects. There it is. We're doing C scripting today. C scripting. Look at example 1. Now, if I go over here, I should be able to PE table the example1.exe, and we can see my ex1 command section is at the file offset 89400 hex. So I'm going to go to offset 89400. Wait, what? 89 example1.exe. What am I missing here? You say you have file offsets this big. Example1.exe, example1.exe. Okay. Well, what is the biggest offset here? Maybe I just type... Oh, yeah, it looks like it's right. I put an extra 0 down. That's what happened. Okay. So this one is this one. We want boom. Go to this. Go. There we go. So where am I? I'm down here. Now each of those, if I remember correctly, I can't just size of from the command line here. Let's pull up a remedy. Let's open. I have to go to the other project. The C scripting is today. Example 1. Start that up just so we can ask, what's the size of the example 1 command type? 40. Okay. So this is 16. 32, 40. There's 1, 2, 3. Man, it's just zeros. It's not the strings. But you give me a section size of 512 bytes. Right, so you can see where the extra stuff is coming from. 512 divided by 40. Yes, it's generating enough. And it's saying the section is big enough that you would have 12.8. So it's not even the right multiple of 40 that it should be. And what's weird is, like, it's not like it always pads it. It's just doing it on this. Oh, wait. No. V size. I don't want to look at F size. That's what's misleading. This is 400 divided by 40. That's more like it. So this is why we're getting 10, right? The virtual size is the one we rely on at runtime because it usually doesn't pad this number. Why is it 400? What's 400 minus 120? 280 extra bytes. I just had a hunch that would have come from these. I don't know how long these are, but they must be somewhere in the data file, right? Generates. It's got to be in there. Start from the top. Generates forward. There we go. 82000. So when I look at the table drop here, 8200 is in this section, I think. That makes sense. So it's a part of the string table, the read-only string table that's in our data. Let me do another experiment. Was that true earlier? The way I had it originally was a little simpler. The description went here. The name went here. And now when I look, let's redo the table. Same size here. Let's reload this. And generate to. Okay, so that's good news. The data strings do actually not go to the same data section as the struct. That's what I expected, honestly. I thought it was odd that I was getting the data string, that I would be getting the string in the section. It just was my best guess as to why this was getting padded. But now I'm back to I don't know where the padding is coming from. And this is exactly what the vetting needs to be. I have to figure out why this happens. With object file editing, I could just get it precise. I could ignore what's in the V size and count the symbols directly and use that to figure out what's actually going on. But since I don't have my PE table set up to dump the symbols right now, I can't see, but I wonder if there are symbols in there for some reason. If that extra 280 bytes actually has symbols that think they correspond to it. Or, I mean, another hypothesis that I'm kind of kicking around in my head is, let's see here. It could be that I need to wipe out all of the incremental nonsense going on around this. Like, maybe a clean slate is necessary for it to stop carrying that section size for some reason. No, so clean slate, it still generates a 400, right? So I think you can see, like, it doesn't necessarily always align to a multiple of 2 when it feels that the padding situation isn't necessary. So there's something weirder happening right there. right? And I definitely have some of them work. And I thought it was the ones with string literals that weren't working, which would then mean, I guess that the reason I should have not thought that is I should see jibber jabber, or worse, like get a crash for trying to dereference something that doesn't exist here, right? Like these appear to actually just be all null now that I think about it. Right? They're just a bunch of zeros. I think what we need to do is we need to spend the rest of the day working on this. This is the actual vetting and research. So where are we at? We're at an hour and 16 minutes. I'm going to say we got about 30 more minutes before I'm going to be too hungry to ignore it anymore. I'm going to want to get up and go get my lunch started. So why don't we take the next 30 minutes to shift from just exploring and describing what's going on to really dig in and see if we can find some tools for figuring out what might be happening here. I also want to compare this to the RPG simulator because, like I said, there was a correlation, and it felt like the difference would be if I went in here and I said, we're not actually going to bake any of this. This is just going to be all nulls. Let me save the correct thing. Like so. And then just go all nulls here. So we'll eliminate the names and we'll eliminate the descriptions. It still generates too many. So that actually doesn't correlate at all. Doesn't correlate at all. Okay, something else is going on. I don't know what it is yet. Let's see. I think what immediately comes to mind is to go back to the RPG simulator file and to look at the cases where it's correct and incorrect. There, because that's a more rich example, I'll be able to see more pattern. So what I want to do is PE table the RPG sim.new.exe. And you see I've got a bunch of them here. And some of them just put like 10 bytes in and stuff. 5 bytes. So it can pad in a single byte type 5 times without getting confused and padding it. But then some of these are bigger than they should be, I think. I'm not sure which, because I don't know the size of each of the relevant types. So wish list of things I had. I wish I could see the size of a type without having to launch the program in the debugger. Maybe switch to red DBG soon or something. Maybe also build a debug info parser. So for now, what I'm gonna do is I'm gonna have to pull up the RPG simulator code because I need to see. Nope, no, no. Yes, close anyway. New context research. I want to do symbol set dot define. Okay, let's start looking at these. I'm gonna make a little. Let's use Scratch for this. I'm gonna make a little correlation table here. So we got RPGST is state symbols. Whoops, not state symbols. Is string 8s. RPGEV is U8s. RPGRL is RPG rule proto. RPG MKV is U8. Another cool trick you can do if you have small consecutive IDs is generate a flag system, by the way. RPG TL is RPG tile proto. RPG TLCL is an RPG tile clause. RPG proto is RPG proto. RPG VR is a string 8. RPG BRST is an RPG brain state. RPG BRTL is a brain tile. And that's the whole thing. Types in RPG sim.new.exe symbol sets. So we have a U8, a string 8. This is a 1, this is a 16. We have an RPG rule proto. I'm just putting down the sizes of each of my types because I don't have a automated solution for that yet, and I want to have it all sitting somewhere that I can visualize it. We already have U8 RPG tile proto. Just do this. RPG tile clause. RPG proto, RPG brain state, RPG brain tile. Now we have to run the debugger. Here, we're going to close panel before coder and exit full screen mode so we can put these side by side. And what we're going to do is we're going to go launch the program. And one by one, I'll size of each of these that I don't know the size of. So size of RPG rule proto. This is the wrong example now. Let's open side project, RPG sim, build, RPG sim.rbg, run, step into it, size of. Now we're in the right context to ask, how big is the rule proto? It's 24 bytes. How big is the RPG tile proto? It's 48 bytes. How big is the RPG tile clause? That's 40 bytes. RPG proto. RPG brain state. RPG tile. And we're good. Okay, so that's all my size information that I needed. I can go back to that. We can read full screen on 4coder, V-split. There we go. Now I can grab all of this information, pull it out, just paste it in. Oops, yeah. 4coder traditionally ignores the first attempt you make to copy anything from outside of 4coder, of course. And then sizes. So this section has 576 bytes. Thank you. BR has 32 bytes. Where are you at? BR is 32 bytes. RPG EV. It's 10 bytes. RPG ST. It's 96 bytes. TLCL. BRTL. PRT. MKV. RL. And BRST. Now, I should be able to figure out the expected count of each of these by just looking around a little bit in the RPG simulator code. Let's see, RPG sim context will contain some of it. So let's say RPG ST, that's going to be the states. There's none here. Let me load this whole project so that I have all the code available. And then let me just scan for all of the places where I define a state. 1, 2, 3, 4, 5, 6. That should be the correct count. So this should have an expected count of 6. Let's do that again. RPG EV. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these, it looks like. Rule protos come from the RPG RL section. And I guess they get defined when I use this macro, which happens 1, 2, 3, 4, 5 times. So I've got 5 of these. Back to the context, MKV, MVK, move kind, that's what it stands for. We have a define macro here. 1, 2, not 3, 4, 5. Okay, so that's a 5. RPGTL. Let's see. This goes down whenever we use the tile script macro. 1, 2, 3, 4, 5, not 6, 7, 8, 9, 10, 11, 12. There we go. Again, TLCL. Looks like this is for the tile script macro. 1, 2, 3, 4, 5, 6, 7, 8, not 9, 10, 11, 12, 13, 14. So that's 14. Context. RPG PRT. We are looking for the macro. There's 3 of them this time. So let's add these up. We got 1, 2, 3, 4, 5, 6, 7. I think these are all the other ones. 8, 9, 10, 11, 12, 13, 14, 15. That's all the protos. So 15 protos all together. Just one more time. 3, 6, 7, 8, 9, 10, 13, 14, 15. Yep, that's 15. that one. Context again. The BR section goes with this macro. That's 2. The BRST section goes with the brain script state macro. That's also 2. And the BRTL goes with the brain script tile macro. That's 1, 2, not 3, 4, 5, 6. So there we go. There's my expected count based on what's in the code. Here's the actual size of the section, and here's the size of each type. So now what I'll do is compute the, let me start labeling these. Section type size expected count actual. This is size divided by size of type. So here we go. We got 96 divided by string 8. That's 16. I'm not doing that in my head. I'm not built like that. That's a 6. Okay. That's good. 10, that's, I mean, that's just gonna be 10. A U8 is a 1. Let's see, a rule proto is 24. So 120 divided by 24. That sounds good to me. That sounds like that'll be 5. That one's fine. Perfect. Okay, here we go. Tile proto, 576 divided by 48. 576 divided by 48. Well, that's 12. This is starting to concern me. Maybe all of these are working just fine. What is different about the example? I don't know. I don't know. It was working perfectly fine throughout the whole RPG simulator. I don't know. All right, let's keep going. Maybe there's still a clue. Tile clause, 560 divided by 40. 14, that's correct. Proto is 840 divided by 56. That gives 15. That's correct. String 8 is 32 divided by 16. That's correct. Brain state is 48 divided by 24. That's going to be 2. Brain tile is going to be 144 divided by 24. That sounds like 6. Yeah, they're all fine. So the whole thing is actually totally fine here. Nothing was wrong. So, dead end. What's the difference? That's the question. Okay, that was a bust. Let me go back to that to-do file, because I'm thinking... See data sections, see symbols inside data sections, count of symbols in symbol set, display of string and integer data in symbol from symbol set. It could be possible to just generate tables out of that anytime you want, which would be cool. editing for improved memory layout and symbol ID references. I mean, this right here is from like size of types was actually just a thing I wish I had. Dump hex from a data section. Okay, so the question is, how am I going to solve this problem? I think the next spot to go to here is I've got a version working and I've got a version not working. Sometimes when I'm in this situation, I am able to figure out why this one's not working by making mutations from one to convert one into the other in little bitty steps. And eventually, somewhere along the way, I get to the point where the code, both examples are running on the same code. I've made enough changes that I made a change, and after that change, I'm suddenly seeing the effect appear, and then I know that I've isolated the change. Or as I try to figure out how to shave away, it pops out to me where the difference actually stands. Right, as I try to shave away the differences, suddenly something pops out to me as I'm going, and I see a difference that seems significant, and I can go in and test that one in particular, right? So I think I'll take that sort of approach. I'll see what happens. Where do I have two examples that can do this? I have one in the RPG simulator project and one in the C scripting project. I think what I want to do first, and I'm just going to kind of make a throwaway here. Let's just throw up a scratch. Yes. Let's make a... how am I going to transfer both in here? Let's just pop over actually to some disk Voyager. We will, what is it? View, properties. Where are the commands here? Commands, split. Okay, help me out here. Control Shift P is for commands, and then split right is Control Shift S. I need to learn that. I like doing that. Okay, Control Shift S. Come up. Here we want source and build.bat. Drop that into my Scratch. We'll create a new folder called build. Instead of calling this source, I'll call this example 1. Or, yeah, we'll just call this the example. And this will be build the example. Yeah, we'll just call it build example 1. And then RPG sim. For this, I'm going to need this. Honestly, let's do it like this. This is why I split in the first place, and then I forgot. We want to stay here in the RPG simulator, and we want to go here into the Scratch. We're building up that out of that. Grab that, copy, paste. Example 2. We'll have to have one here for build example 2. And I don't think I need anything else to build the RPG simulator except the base layer DLL. Yeah, all the rest of this is independent. Oh, I probably need... No, that's for the viewer for sure. Okay, so that goes into build over here to get this all set up. That should do it. Now, let me pop in right here. I want to do another transfer. We're going to come over to the scratch space. We're going to look at each of these builds until I get them both kind of doing what I want. So this is supposed to go into example 1. And it builds example 1. Now example 2 is supposed to go into example 2 and build the RPG simulator and generate a file called example 2. Right? That's how it looks. RPG sim.c should do everything else the same, right? Except there might be things I'm forgetting. So let's pop over there to that scratch space. Try and see if these guys can build. So that builds example 2. Fatal error cannot include Mr. Forth base.h. So we're going to need to include see Mr. Forth source. Try that. You don't see it though. Mr. Forth source, Mr. Forth base.h. It should be right there. Okay, sometimes I forget that you can't use that syntax when you're in a batch file. That's for bash files. I think this should work though. Right, so we need a few more includes here. Let's just spread this out. Set ops to ops and a little more and a little more. Let's see, Mr. Forth source dependencies. Dependencies. It should be right there. You don't see that right there? Oh, I lost the source. That's a mistake. We want to keep that. So the base layer demands that the linker use some of these. So I need to drop in one or a few of the libraries here. Probably just do it like this. Come right here and be like, let's go lib right there. Set lib equals this one. Set lib equals lib, and I might need more, so I just do whatever. Just grab that one and that one and that one. That should do it. I could also just, I guess I'm not actually enjoying this. I think I would be happier like this. Cannot open winmm.lib. That is interesting. Is that just because it comes first? Is that the issue? Is it like I can't actually define add libs in this way? Is this not how it works? Yeah, that's not how it works. Okay. How do you do this if you don't want to do 2 steps? Maybe I just need to do 2 steps to build this one. Maybe that's the difference. Shit. Okay, let's try this. So I do -C. Then all it has to do is make the... Yeah, we want to drop these. They're not relevant. We want to just go, boom, here's how you do it, right? And then so it's building, but it's not making an exe. And then I would go link, and that's where I would drop all the libs together with rpgsim.obj and set the... Let's see here. We want to do a no logo, and man, there's all these options that I still want. I want to generate a debug info, maybe. I want to make sure we're not doing incremental. Just okay. Let's just go link opts here. Set link ops equals, and then this is no logo, default lib, opt ref, incremental no, debug. So link options, lib libraries. rpgsim.obj kind of goes here, but we still need to set dash out, and that's going to be example 2, and you're not going to go like that. We're going to go like that. Well, this is just running the RPG simulator project. Build example 2. Cannot open input file winmm.lib. Oh. How does it work then? Oh, when I do it on this system. Okay, let me see something. When I go back to the RPG simulator, and I say, okay, we're going to run this project for a bit, and we're going to set the local configuration of this project to use diagnostics. And I'm going to build, and that should build the RPG simulator. With diagnostics enabled, it'll show me the whole line for the command. Turn off line wrap, and it'll also show me the whole line for the link. Although the name of the link will be really complicated because I have to give it a full path. Out, no logo, opt ref, incremental node, debug machine. Okay, and then it just winmm.lib works. So build example 2 should look like dash out example 2 options, no logo, default lib, opt ref, incremental node, debug, and machine x64, and then libraries winmm user environment.lib, advanced APIs 32.lib, and user 32.lib, and then the object file, right? And so that should do it, but it's saying it cannot open the input file winmm.lib now. Why? It works just fine when we run it from here. Um, huh. Huh. What? And I've got this basically exactly mirroring the build that is working right here. So here's this one. It looks like this. It works. Yeah, I considered that it might be that the VC vars all is different, but 4Coder was launched from this command line. They should have the exact same environment. Um, I mean, a different way I could demonstrate it is, or to myself, is I could try to run the batch file from 4Coder. I can do that pretty easily. What I would do is I can, if I make one called build.bat and then I call build example2.bat and then I hit Alt M, it'll go. And now it works. Yeah, that's weird. So it is working if I run it from 4Coder, even though 4Coder shouldn't be seeing different arguments than the command line. Like, so here, build, fail. Launch 4Coder, Alt M, fail. Okay, now it's busted. So I'm gonna assume somehow the command line lost its setup VS isn't working correctly anymore. Now we're set up. Somehow maybe I had a good 4Coder, but not, maybe I didn't launch 4Coder. Maybe 4Coder was open from like yesterday or something and I'm just wrong. I didn't actually see the spot where I launched it. I could have sworn I did, but maybe I just launched the second one, the one with the sign. That's super confusing. Now if I build, yeah, okay. So it was exactly what you thought. I was kind of thinking it might be something like that because it's weird, but I'm not used to the command line being the one that's not working. Usually what happens is I forget to set up VC vars when I first launch 4Coder, and then it doesn't have the correct environment variables to run the scripts. But this time 4Coder was initialized correctly because I probably ran it off of another environment from yesterday or something and just forgot. Like I can build, so we can come in over here, we can go, okay, build example 2. You don't need to echo the link anymore. We figured it out. We don't really need build.bat in the Scratch anymore. Okay, so we can build both of them. And if I look, there they are, example1.exe. But example 2 isn't named properly. I should be calling that example2.exe. Let's go into the build. We're kind of done with this split. Let's just get a clean slate. I don't want to lose the base DLL. And then build 1. Build example 2. Okay, there we go. Now I've got an exe for each one. Example 1 generated with its own obj file. Example 2 first built rpg sim.c and then linked that into the exe. So those are some of the differences. Now what I want to see is, does example 2 look like the data sections are still right? Let me grab all this information here, copy it out, and then pop back over. Oh, I lost the good Scratch with all the info. Silly, 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 silly. Okay. These all look about right, though. Like, these are all familiar numbers. Um, RPGTL section. You're looking at the tile proto. The size of the tile proto is 48. 576 divided by 48. What is that? It's like 15 or something like that. 12. Okay. And the tiles are defined by this. I haven't opened all the code. The tiles are going to be in this and this. And there are 1, 2, 3, 4, 5, not 6, 7, 8, 9, 10, 11, 12 of them. Yeah. Okay, that was the only one that I wasn't super confident about. And it looks like they're all the same. So these data sections still generating the way they should. And if we look at PE table build / example 1.exe, that's the code from before. It's wrong, right? It's generating the section with that extra padding that I don't understand. So I have set up here a side-by-side comparison of a version that's working and a version that's not. I don't know why the version that's not working isn't working, but I'm lucky that I have a version that is, so now I can start to iterate on the spots where they have any differences and figure out what might be happening. I think I will do that when I come back from lunch. I think that that is a good spot for me to go and start some lunch and stretch my legs and let this first pass announcement get out of my system. So to finally wrap up, reminder for everyone checking this out, if you think the symbol set stuff looks cool, could be cool to have, I'm still working on it, and I'm able to work on it because I fund all of this with MrForth.com membership. And if you become a member, one of the perks is you get to see this repository in development, so you could start grabbing it now. Like I said, there's a bug in it already. We're trying to fix it right now. This is going to be undergoing a lot of iterations. The examples are going to get better. The descriptions and explanations are going to get better. The code is going to work better. I'm going to add tools that go with it over time. So all of this stuff is going to start growing, and you can become a part of making it happen and get early access to all of it if you are a member. So check that out if that intrigues you, and I will be back later to keep working on this bug. That's not the right thing. So I'll see ya later.